As a continuation to the problem with Charlotte and her second semester project, where the length of time in minutes related to the tip in dollars, and to see whether there was convincing evidence that the customers who stay longer give larger tips. Let's take a minute and try a confidence interval. So let's construct a 90% confidence interval for Charlotte's tip problem. So when we go through this, it's going to be the same type of thing that we were doing. Remember, we're talking this whole time about slope and the change in slope. We wanted to see whether it was going to increase, right? If we had the time that the person would stay, if the tip is going to be going up. And in the last problem, what we were looking for is we said that we failed to reject the null hypothesis. We do not have convincing evidence that parties who stay longer at buffets leave a larger tip. So we felt like this was not increasing. The null hypothesis was that it remained the same. However much time you spent, you were given the tip you were going to give. And it wouldn't increase. This was the HO, where the tip wasn't greater, and this was the HA, where the tip was greater than 0. So we did not reject the HO last time. So let's see what happens when we try to do a confidence interval. Confidence interval is very similar to what we've been doing. Keep in mind the starting point is your B, your slope, and you're going to add or subtract the same as before, your critical value, which is T for these, the same as before, and your standard error of the slope. So be careful not to use your standard deviation in that spot. It's the standard error of the slope. And if we look at the past problem, we have the B value straight from the calculator. Now the tricky part, to try to find the T value, we need it to be 90%, we need the T chart, and the degrees of freedom are still 2 less. I believe we had 12 receipts that we were looking at, so we're going to be using degrees of freedom as 10. So when I look across to 90%, 10, I'm getting a T value of 1.812. We also have the standard error of the slope calculated as 0.024481. So we want to add and we want to subtract. When we subtract, we're going to get negative 0.01423, and when we add, 0.07449 is what I ended up with as my interval. You know how we always say we are 90% confident. That the interval negative 0.0423 to 0.07449 captures. Now be careful of what we're estimating. This whole time we're talking about the slope, the true slope. The true slope of the population for predicting time at a buffet and the tip amount. Now be careful when we look at this. What we were testing before was the null hypothesis and the alternative hypothesis. The null hypothesis was where it equals 0, the slope, and the alternative hypothesis where it was a greater than 0 slope. So to test the null hypothesis, remember we want to look and see, does 0 lie somewhere in this interval in here? And yes, it does. So we can't really reject it either. This gives us more background as to why we shouldn't reject the slope remaining the same, because it's within that interval.